let us start the 6th lecture on Introduction to Artificial Intelligence. You're all most welcome, and I see many faces who have actually sat here through the entire course on the lectures. And then, of course, I cannot see those of you who watch the recordings, but I keep tracking you as well. And clearly, people have there's of course many students on the course, but I'm also happy that the retention rate is low, so people actually keep doing the course and do not drop it, which is a nice thing. There was less feedback from last time. I think there were roughly 20 students who provided feedback. I went through that. Nothing that I can maybe change right away, but then comments on maybe on the examples, on how to present heuristics and so on in lecture 5. And feedback is very welcome. And everything that you provide will, of course, then be used either this year or then incorporated in the material that is then available for next year's students. But today we have a full lecture ahead of us, and the topic is slightly different. I also try to reflect this by having a slightly different cover image. So less futuristic and more maybe, I wanted there to be people. And then there's a robot, but people still. And the topic is on impact and ethics of AI. And if you have followed what I've been explaining to you in the previous lectures, you might have realized that I'm actually quite a technical person. And I worry more about how to solve integrals, how to implement things, than actual impact and ethical aspects. Because that's not my special area, and as kind of a tech person, I easily get excited about the technical details. So actually preparing the material for this lecture has also been kind of an educational journey for myself to look at different aspects and different viewpoints into these topics. And I hope that this also is maybe thought-provoking in some sense to you. And I hope that you shout out or put up your hand if there's something that you want to comment on, bring in perspectives and so on. Okay? Is the deal? Some of you are nodding. Yeah. Okay, so what are we going to look at today? We look into, societal impact, fairness and biases, and transparency and accountability, and ethics of AI. And we will try to finish with a recap on these topics and then on all the course topics. Before we continue, I realized that I need to switch slides. So, ethical aspects, impacts, and then let's see how much time we have for the recap. It depends very much on how much you want to discuss things, but I have included a short recap of the topics in the end. Okay, so we only have limited time, so let's get going. As a first step, I ask you to take out your smartphone, or some of you have laptops. You can type in the address right away just from there, and give me some input here. What comes to mind from impacts and ethics of AI? I'll let you think of that for a minute or so. Are you all done? Anyone need more time? You're quick at typing with your smartphones. Okay, let's have a look. Interesting. So the interesting part is how things change over years. So for many years, it was usually so that there's like a big thing in the middle, and that's Terminators. And I cannot see any Terminators there now. But now, like, there's like...
There is Skynet scenario at the bottom.
Ah, Skynet scenario. Okay, so that's Terminator, that's true. So Skynet is mentioned. But I see many like kind of like data-related things, bias, and then also like there's all these kind of regulation, law, copyright, and so on. So maybe like questions like this kind of often like reflects what's being kind of topical recently in the news and so on. And of course then like new methods, models come out, and that of course also affects then like how people view these things. Okay, so let's have a look. How I say it is that for a long time, AI really was something that was like purely developed in research labs. And people didn't really have that much concern about how it was used, because it wasn't used. People ran MNIST and reported what kind of like precision and recall they got on these benchmarks, and that's kind of it. But what has kind of happened in the past 10 or so years is that many AI methods have actually kind of like packed their things and left the lab, like moved to college, like left their parents behind, which kind of means that these AI methods are actually being deployed into use. And in the use that they're actually like, they're used in the real world, so to say. And as you might remember from our previous lecture, we discussed data and so on. So data from kind of like out here, like the real world, is typically quite chaotic. And you don't really kind of know beforehand what the model will encounter. And you cannot observe everything in the training phase. So then things like robustness really are put to test. And this pretty much means that these methods, they encounter new problems. They're being used for things that they weren't designed for in the first place. There's challenges, and there's different issues. And those challenges, problems, and issues, we try to like dig into a bit today. On the other hand, like these new methods can also have like disruptive effects on established ways of working, thinking, doing things. So really, if you think like, well, before the wheel was invented, then well, people moved around in other ways, but then with like us inventing the wheel already many years ago, then actually things changed. And it's not long ago that I talked to a person who works in like business, and he had talked to some CEO of a big company who had been saying that this generative AI is the biggest disruptive innovation since we invented fire. And I find that's a bit of a bold statement. I think it's more than like more at the level of inventing Excel or something like that. But inventing fire probably changed more things than generative AI. Well, I might be wrong, of course, but that's just my feeling. But anyway, what we have been seeing in the past years, and I assume that we will continue seeing, is that AI is actually like affecting many areas of science, many areas of business, and areas of life in general. So then like AI is spreading into tools that then are used in health, economics, natural sciences, arts, and so on. And that's kind of why also I try to have the visitors on this course represent different areas so that we would actually see and experience the change together. And I assume that things will keep changing also in the future. So about the disruption, there's kind of a clear rationale why this is happening and why this is kind of like desirable in a way. Because like AIs are typically good at repetitive tasks. You know, when you are supposed to do the same thing over and over again, you might stay alert for the first 5 times, but then you're maybe not that focused then on the 55th time to do something. AIs can also endure pressure and they can operate in hostile, also like physically hostile environments. Think of the Mars rover that has a small helicopter with it. Of course, you cannot control that helicopter from Earth because the radio signals take so long to reach Mars. But instead, you can pre-program the small thing to fly around and do something. And of course, then it needs to have some logic then to know what to do in like surprising situations and so on. So that's a good example of a hostile environment. We cannot send humans there. Well, partially also because it's expensive and we might not have all the technology yet. But then also there are many environments and many tasks that we might rather leave for AIs to take care of. One can also say that at least some types of AIs can think logically and without emotions, and which would mean that they could make like rational decisions with less or no mistakes. Of course, then let's say you would apply a large language model for something like this. It's a bit unclear whether it takes emotions or learned patterns that we call emotions into account or not. So of course it also depends on the type of AI you're looking at. So if AIs then can do things, so will we all lose our jobs, or those of you who are studying, will you ever get a job because AIs are so good at everything? So I'm quoting John F. Kennedy here, who said in 1961, "The major challenge of the 60s is to maintain full employment at a time when automation is replacing man." And, well, at least this far, every technological shift, like starting from probably inventing fire and inventing the wheel, has ended up creating more jobs than were destroyed. Of course, it might not be the same jobs that keep existing, but there might be new jobs and new tasks that become important. But at least this far, things have worked that way. So when particular tasks are automated, becoming cheaper or faster, we need more human workers to do other functions in the process that haven't been automated. And of course, like this far, automation might be like automating things like assembling things or putting stuff in boxes or so on. If you have seen Charlie Chaplin in modern times, he keeps doing this tightening some bolts all day long, and many of those jobs have disappeared because of machines before. But now, like maybe the buzz at the moment is that many jobs that might have been seen as kind of like safe from automation because they have been considered to require such human supervision that they haven't been we haven't been able to automate those jobs. So they are now kind of like in in danger, so to say. But I still believe that we are not going to be all replaced. I see these things as tools that are hopefully going to make our jobs easier and maybe more focused on the things that we find interesting. So, if then AIs are so important and will be part of a bit everything, should we all move to work in IT? Should we all become AI engineers? Would that be the solution then? So, who's going to maintain the machines? I think the machines will develop also there. Who's going to improve the machines? I believe the machines will have a central role also there. So I would say that no, I don't think that we should move everyone to work in AI. Maybe instead to have everyone at least have some basic understanding about these things. Whether people ask me, like if people ask me, I would say that yeah, everyone should take my course. You should all come here and learn about AI, at least on this level. But then whether you all should work in AI, that's a different story. But I think like these tools are not only developed for everything else, they're also developed for AI development. And well, coding is a big part of AI. And already now I think we have quite useful tools to help out with that. Has anyone of you, like, how many of you can code or consider yourself capable of writing code? How many of you use Copilot or something else to assist you? I'm surprised that less than 50% of the coders do that. Yeah. You might of course be so efficient and good that you don't need that. That must be it. Yeah. So then another part of all this is like human-like intelligence. So if you remember from the first lecture then, and then we talked about machine learning, and then last week we talked about neurosymbolic things and so on. So in AI, if you have algorithms do things that we think are intelligent, like to have computers do things that if people did them, we would consider that to require intelligence. And that can be seen as kind of like replicating human intelligence, or to explain how human intelligence works and then like reproduce that human-like intelligent behavior in computers. And now again, like this week I've been seeing that like, was it Elon Musk or who said that we will have artificial general intelligence, like really like actual intelligence, human-like intelligence in machines, was it in 1 year or something like that. And these things come and go on the social media. But if you're seeking human-like intelligence, is there kind of like some like flaw by design in that? So I always think of Einstein. Not always, but when I think of this. And Einstein said that only two things are infinite: the universe and human stupidity. And I'm not sure about the former. So do we even want human-like intelligence for most tasks? Well, humans are really good. We are very generalists in what we do. We can tackle different problems, but we are also kind of like unreliable and so on. We are good at kind of like being robust to like if something surprising happens, but to most things we automate, we probably want something that is actually like non-human in intelligence. But of course, it's a grand challenge to consider AGI. In the word cloud, like aspects related to fairness and biases, like popped up many times. And I would say that an AI will only be as fair and unbiased as we make it or train it. And often the training data reflects current biases we have in society, and the AI we train on that data might end up amplifying those effects. Simply, if you think of some general data distribution, if there are, for example, multiple modes, multiple different ways of thinking, for example. So when you then train models, you typically need to make some simplifications. And as you remember, the choice of model family is there's someone actually engineering the AI. It's a conscious choice someone does. And what then typically happens is that you kind of fit your model to that one dominant mode. And all the other modes that you have in the data, the other clusters of things, are kind of like ignored. And this typically happens. And this can lead to like seemingly neutral algorithms. You did not want to design a racist algorithm, for example. But seemingly neutral algorithms may then like end up reinforcing inequality. And this is quite a widespread post from social media from some years back, 2015. Google Photos had been out for many years already, and they had this feature that it tries to automatically classify things in photos. And then there's a big scandal then, because then actually like people with darker skin color were classified as gorillas. And that's not easy then to fix. Like, I remember what they actually did in the end, I guess, was that they just removed the category of gorillas. That was the quick fix, because these models are black box. You cannot like tell the model that now you should not be racist anymore. So it's actually like not easy then to tackle these things. And I guess this kind of like slipped through their testing. Probably like the data that they tested the thing, because, well, you can only guarantee quality by having some test data set and hoping for the best. And that process was clearly not very thorough at that point. And like these kind of issues, I think, are tackled. People are more aware that this can happen. So then people are aware of that what you should take into account when you test models before shipping them. But maybe the kind of problems are less extreme in this sense, but it doesn't mean that they have faded away. There are a lot of these examples that people have thought that they have a great model, they have trained it with some data, and they have just put it in production. And then there's been a scandal on the news that it didn't quite go well. So for example, there was this model that was used to predict whether someone will repeat doing crimes after they are released from prison. And apparently the model, basically what it did was that it checked that whether there was a African American person and then tagged them as a possible future criminal. Or Amazon had an infamous recruitment system that was trained with the help of their existing like data from their existing pool of employees. And because like a dominating share of the employees that they had at training time were males, then the model they trained for making like new recruitments like thought that, well, like you have like this many males nowadays, you probably want to favor hiring more male applicants. So, and that slipped through into production. Or then like Facebook, there's so many scandals around Facebook over the years, probably because they have so many like sources of data, and then maybe also then like all these things that they run are maybe like a bit risky in many ways. Yeah, many examples. And then like, what have people done? Well, teaming up with the Pope is one option, but then that might not actually solve the technical aspects of it. And a part of the problem behind this is actually these models, well, many of them being very black box. So we are not being able to see what happens inside. And many of these trained models are actually quite sensitive to small, tiny details in the inputs. So this is this is an example from a paper from 2015 by some good researchers, and they showed that this like convolutional neural network model, similar models that we discussed on the deep learning lecture. So by hand-picking and tailoring the input, you can actually confuse them. So a human would look at this image and see nothing. The model sees a robin here. Or this is a cheetah, by the way. This is an armadillo, and this is a panda. Or then, well, this looks like just like noise. But you can also then tailor these images so that they actually look like something. And this image here is classified as a penguin. This is classified as a starfish. This is a baseball. And this is a guitar. And actually, like by hand-picking these things, you can actually confuse the model. And it's all fun and games as long as it's on this level. But then apply that to a stop sign. So, for example, my car has like this detector that looks at traffic signs and so on. But even those models, there's probably some neural network running in the background doing the classification. And actually, in this paper here, the author showed that by carefully tailoring where to put stickers on these traffic signs, you can actually confuse the model to think that it's something else. And then, of course, then it's not fun and games anymore. Then it's actually like a malicious attack. It can actually cause an accident, have a car then like run through a stop sign. So these adversarial attacks are basically when you tailor the input so that you trick the model. And especially deep learning models are quite vulnerable to this because it's also hard to know what they actually have learned and what's happening inside. More examples of that. Also, we can take an existing image. This is clearly a panda. I think we all agree on that. Yeah. Then we add some tiny bit of tailored noise, like basically this, multiplied by some small number, and it still looks like a panda to us. But now, this trained model here classifies this as a gibbon with this extremely high confidence. So that's clear like an adversarial attack. You know, Teslas have these traffic lane detectors, as have most cars. I guess most new cars have that. It might even be some EU thing that you need to have like a lane detector in the car nowadays. I'm not sure, but there's like all these things coming in. So this study from a couple of years back showed that you can actually then like confuse the Tesla autopilot by having these stickers or the markers on the road. Basically, it's a physical adversarial attack. And simpler things work. You can also attack like Google Maps by just having a whole bunch of smartphones to think that, make it think that there's a traffic jam, because it basically tracks smartphone users. You're basically providing data on where people are, and if there's a lot of people stuck in traffic, it assumes there's a traffic jam. So this is one way to free up traffic then by rerouting everyone else. Then of course, there are all these kind of malicious things that you can do, but then also the training data per se, if you have a machine learning model, you need the data to train it, to learn from. So where to get that? And especially if you remember when you talked about foundation models, these models require an immense amount of data. These models are typically not very data efficient. You don't need to read through the entire internet to know everyday things. These models basically do need that. So then the data is often scraped online, probably without much respect for copyright. And I think there's been news about Copilot, ChatGPT, Stable Diffusion, and you name it. Basically all these big models There's been news about someone suspecting or someone suing these companies for the use of data or how the data has been collected or managed. And then there's a lot of these cases. If you read the news, there's like every now and then there is a new lawsuit about this. I'm also very concerned about like privacy issues. So I would say that this is like a major concern. This has been kind of on the map for many years. So I'm kind of happy if I get kind of like relevant ads. Maybe something I'm rather see ads that maybe make a difference, kind of like if I'm actually planning to buy something. So I'm not super concerned about like Google targeting ads for me, but these kind of then when like people try to target political messages or impact how I see things or impact my opinions by manipulating me, then I'm more concerned. So I'm not, that's a bit weird, I'm not concerned when people try to manipulate me to buy something, but then when people try to manipulate me to do something or have a specific opinion, then I'm more concerned. Maybe I should be concerned also about the buying part. But anyway, many of these services that actually we use, they require data. So I wouldn't say that data and sharing data is like evil or bad per se. We benefit from that as well. We get personalized experiences and so on. But maybe also what the EU tries to do is to like let us have more control about what we share, and also then have the right to kind of be forgotten if we so want. There's also a methodology called differential privacy, and I'm just mentioning that here because I find that it's important that after taking this course, that at least has been mentioned. So differential privacy is a technique that uses like statistical methods to like maximize like accuracy, while then like minimizing the impact on what kind of private data needs to be shared. So it's a whole like field of research, how to kind of actually provide those services without actually comprising sort of like your private data or actually needing to have access to data that actually concerns exactly you. So more like aggregate measures and so on. Transparency and trustworthiness. Can we actually trust AI systems? Some people are directly shaking their heads. No, you don't trust anything. Yeah, it's then like someone said that. Yeah, anyone who knows about these things, they don't have any Alexas or Siris or anything at home. They only have electronics from the 90s. And if the printer makes some weird noise, they hit it with a baseball bat. Yeah, I'm maybe partially in that category myself. But I think like it's not that bad. And maybe I need to say that I try to tune this whole lecture into a more positive tone, because one year when I was lecturing about this, I kind of like realized that everything I said was negative. And you shouldn't see these things as just purely negative things. I think there are a lot of good things here as well. And I think that AI systems can be trusted, but maybe taking the following pillars into account would be good. One aspect to look at is fairness. Training data and models should be free of bias. That's easier said than done, quite frankly. But that should be the goal overall. Things should be robust. Also like secure, not vulnerable for tampering or comprising data, not vulnerable for adversarial attacks and so on, but also they're robust in the sense that they can act even if they encounter things that weren't there at training time. We would of course like things to be explainable. We would like to be able to interpret what's happening, and also then like if there's a decision made, we would like to be able to learn from the model how it arrived at that decision. And then there's like the fourth point here, it's like lineage, like clear details on development, deployment, maintenance. Like, I'm a big fan of open source frameworks because then you can actually, at least you have a chance to look into the thing, see how things were implemented. And then if there's something dubious, you kind of, at least you're informed about that. That's why I have a new car. My old car broke down last summer, and I bought a new car, actually like a new car. And the car salesman then was showing the car, and then he was then like, well, this car, it has AI. It comes with AI. And that sounded very interesting. And the AI in the car, it's one button on the wheel. And when you press the button, he explained, it will follow the car in front of you, kind of like. It will maintain the distance, follow the lane, look at the traffic signs, know the speed limits, and it will be all good. If the car stops for red light, then in front of you, the car will slow down and stop. And that sounds, I had never driven a car like that. So then I asked him that, does it actually work? And he was super happy about this, like, he was so excited. And he was like, yeah, most of the time. And this is the thing, that's why I don't trust the car a bit. All these features are nice, but I don't trust the car. There's no trust relationship between me and the car. I'm convinced that every once in a while it just decides to kill me by turning the wheel and crashing into another car. Because I don't know how it's implemented. And I don't actually even want to know, because it's probably some small neural network trying to do something very simple. So yeah, I don't trust my car with AI. But I would be happy to see how it's implemented. And if it's good, then I actually might know when it's trustworthy and when it's not. Question?
Yeah, about the third point, as it said that in some case we need to understand what AI do to produce something. But like in some case, AI is able to, let's say, discover something or math or to solve some unsolvable equation. So in those cases, are they kind of contradict each other?
So the question, if I try to like...
I mean, because the AI, we don't understand how AI works, and magically is able to invent some material, new material, or to solve some unsolvable equation that human, like for a long time, are not able to do it. So this third point, is it kind of contradict, so we prevent the AI to do what it's supposed to do without we understand them?
So the question is that about the third point. So, for example, if an AI would actually solve some equation or theorem that is unsolved by humans, so would that contradict the third point? I wouldn't say no. Then, of course, especially in the case that the AI can come up with a solution to something that we haven't been able to solve, then definitely you would like it to be able to explain how it arrived at that solution. So it's more about then kind of seeing what led to it solving it, maybe. And maybe then, like, if you think of like human-like AIs, and this might also like apply to large language models. So are humans explainable? Yeah, I wouldn't say so, yeah. So like of course I can ask you how you arrived at asking that question. And you can of course explain that, well, you were thinking of this and then that led to it and so on. But it's still your explanation, and then it's up to me whether I believe you or not, kind of. So it might also just be you hallucinating some nice answer. So yeah. So, and in that sense, like, we maybe are more harsh on these AI methods than we actually are towards other humans, which I think we should. And then one thing also that I want to stress is that, well, you know now that there's not just one type of AI. There are many types of AI. And the choice of like right AI approach for different tasks. And if you think of them like the symbolic AIs that we discussed last week, and like sub-symbolic things like machine learning that we discussed on other lectures, so then they both have their strengths and weaknesses. So depending on the tasks and problems that you want to tackle, then you should choose the right model. I've showed you so many examples of hallucinations and things, but I find this quite funny. So I'm asking Dolly 3 to draw an empty room with absolutely no elephant in it. It's quite explicit, don't you think? It should be quite clear what I don't want to have in the room. It generates 2 images. So here's an empty room with absolutely no elephant in it. The space is simple and unadorned. Well, here, fine. What do we have here? Is it trying to be cheeky? No, it's just hallucinating. So, yeah. So, do I want my car to have an autopilot that basically is some like large language model driving the car? No, I don't want that. I tell the car that let's drive to Tampere with absolutely no crashes. And every second time it succeeds. So, yeah. So after this course, I hope you have this healthy suspicion towards AIs on one hand. And on one hand, you're super enthusiastic about things. This is kind of the goal. So, because these things, here it's easy to see when the model fails. There either is an elephant or not. But then when we are looking at something more complicated, then it's a lot harder to see when it goes like off track and do something immensely stupid that a human would never do. Misinformation. And now we are kind of like, I have some slides about concerns and things, but misinformation is actually one of the actual concerns I have. Because like generative AI models can be used for generating, well, they are tailored for generating like fake text, fake images, fake videos. And of course then like, if you can generate fake stuff, isn't that a perfect tool for creating misinformation? Or then just filling the internet with nonsense, which I find that is kind of slowly happening. So the models that we already have like, can create quite plausible images, for example, of Pope Francis wearing this like ridiculously expensive clothes. These are like fake images. Or images of Trump getting arrested. There was this social media scandal at some point last year about that. Oh, and of course, then if you look at generative text models, all kind of nonsense that you can generate that still looks credible. And one of the scandals from this year, I think it was some like month back or something, was like this deep fake scandal about Taylor Swift. And that's again like an example of where actually these tools are used. They are being tailored to be used for fake and nonsense information. And then someone puts them to use, and then that's what we get. So I'm actually concerned about this. Good old Arnold. Yeah, another thing that we should maybe be concerned about is weaponization of AI. So autonomous systems can be used for warfare or terrorism. And like, of course, there's like various degrees of autonomy here. But when weapons start deciding things based on sensory input, we are definitely in the realm of AI. And of course, then like there's been like smart landmines and so on around for decades. But then when we talk about autonomous drones or aircraft or submarines or tanks or robot dogs with huge cannons on them, then I would be quite concerned to have these police dogs patrolling the streets if I would know that they are controlled by some neural network model that suddenly might start hallucinating. So I have my concerns here. And then there are like every now and then I keep picking up this news about then like sounds like a bad idea to have an artificial neural network choose targets in a gun. This sounds concerning. It's already from 2018, so this is no new thing. Okay, let's have a break. During the break, you could, I just open up this like here. Let's talk about accountability after the break. And there's this Pressimo link that you can access. And during the break, tell me, who do you think is responsible for the actions of an AI? Let's continue 1:15, and let's start by looking at the responses that you have put in. Let's continue. Okay, so then before the break, I asked you to go in and click that who is responsible. So is it the scientist who originally developed the AI models and methods? Or the developer who coded up the AI? Or the deployer who actually then took the AI and deployed it and put it into use, sent it away? Or is it the AI itself that is responsible for its actions? Just going to refresh this. So, some think it's the scientist, some think it's the developer, and most think it's the deployer. And this kind of agrees with I think I've asked this question many times from different people, and this is how it's seen. That's kind of like the one who sends it away has the kind of most accountability. Well, then maybe the understanding of actually what happens inside might go the other way around. That probably the scientist knows that probably putting this model to drive a car is a bad idea, while the deployer might just see it as an AI that does something. No one thinks it's the AI itself. If we would have artificial general intelligence, if Elon Musk's tweets are like in 2 months that now they have AGI, would that change anything?
Is it provable that this is AGI?
Sorry?
I mean, we have to see if AI is actual AGI.
Yeah, we need to see where it's actually AGI. And probably even if we would fulfill some criteria, then I'm sure Gary Marcus says it's not actually AGI anyway. So, yeah. Oh, it's updated. That's cool. Okay, let's continue. So, but that just means that it's actually the accountability that's tricky, because I think like all of these parties are maybe to blame in some sense, but like from different points of view. So it's a bit tricky. Of course, then if you look at the law and so on, that's sort of the one thing. But then if we ask the person on the street, then, and it's also very much about how things are kind of marketed, what the public thinks about these things. So this far, people haven't been blaming the scientists that much. But I remember there was this thing on the news, was it last summer, that some researchers called for a 6-month break in AI development, which felt much like a publicity stunt of some kind, to me at least. Then also apart from the EU and the AI Act, we have some older laws for robots. And Isaac Asimov came up with these 3 laws of robotics that say that a robot may not injure a human being or through inaction allow a human being to come to harm. That was the first law. The second one, a robot must obey orders given it by human beings except where such orders would be conflicting with the first law. And 3, a robot must protect its own existence as long as such protection does not conflict with the first and second law. And of course, these are written by an author for a book, but they're actually quite smart. Then how to code this up into an actual food delivery robot is another story, and maybe not practical per se, but on kind of an idealistic level, I think this is how we want to see it. We want to be kind of like this, still the masters who control the AIs. Our actual legislation is nothing like this. I don't think this is incorporated into our laws in any ways. But actually, I think in many ways the current legislation is taking into account many aspects of AI. So I'm not that concerned that we would kind of be completely behind on that front. Of course, there's these regulation and legal things, but then actually also there are these things that kind of go beyond that. And from a human point of view, the crucial question is that can an AI be allowed to make decisions of life and death? And technically, my car is probably already doing that when it tries to keep to the lane and not go off. But actually, active decisions. For example, if you think of deciding that who gets some medical treatment and at what costs, that's kind of already that. And then there's this so-called MIT experiment, the trolley problem. So kind of if someone needs to decide between 2 bad options, I think most of us still prefer that decision to be made by a human being. Well then, I guess self-driving cars might at least implicitly already make such decisions. The MIT moral machine is actually this sort of web page where you can go, you can try it, that presents you always 2 different scenarios. So for example here, you have a homeless person, a dog, an elderly person, a cat, and a child. And if the car here with a family and a cat just drives over these, most of these people will die and the child will get injured. And if they turn the wheel, they all will die. So what would be the right decision here? And basically this boils down to actually do people value the life of a cat more than the life of a dog? Or the life of an elderly person less than the life of a child? And some of these things apparently are quite universal, while then others then actually people are in disagreement. And there's also cultural differences. And this web page has been collecting data for years, and there's been several publications analyzing the data that they collect and so on. But for example here, so sacrificing homeless person, cat, dog, and elderly person, or this family here. Turn the wheel or not? Who would turn the wheel? Who would not turn the wheel? Okay. how about this then? So either there's a probably like a mother and a child killed, or then 2 adults killed. If you were the self-driving car, for example, now, which one should they sacrifice? Who thinks the mother and the child should be sacrificed? That's a question, I guess.
Well, one detail that I noticed in the previous one that is different from this one is the fact that the crossroad sign says that the pedestrians can walk. Therefore, it is likely that there is a red light, therefore the car would stop and wouldn't actually drive into anyone. And even in the previous one, the car shouldn't be trained, oh, kill this one or that one. It should be trained, stop and minimize the amount of death.
Yeah, but if actually like a binary decision, you need to kill either party. But of course, then the traffic light, that's a good point, because then are they actually jaywalking, or actually is the traffic light red for some party?
Except for the animals and maybe the child, they have made a conscious risk to take that.
They're taking a risk.
Take the risk. While on the other one, where the light is green, they didn't.
Yeah.
So that could be taken into consideration.
Yeah, that's a good point.
Of course, it has to do what is cheaper for repairing the car.
That's also one aspect. So I guess like maybe in the future, the self-driving cars will have like a menu that you can like pick. You can put like a dollar sign on the life of different things, and then you value your car at a certain level. So then like you adjust the car's choices by that. I don't know where this is going, but who would turn the wheel and kill the adults if you are the self-driving car? And who would not turn the wheel and kill the child and the mother?
But can we turn right? It looks lower than
Okay, then, well, no one dies in the car because it's on its way on its own, but it either kills 2 cats or 2 dogs. Who would kill the cats? Who would kill the dogs? It's like 50-50. Question?
I would likely attempt to drive in between and hit 1 cat and 1 dog.
This was no trick question. So, but okay, these are a bit kind of like dark, these scenarios. But then, it's just to show you that, like, we are faced with choices in our everyday lives. Not choices like this, I hope, but with other choices. But we are constantly making decisions. And often, there is no like absolute great or good decision. We need to choose between bad decisions. And this is just making it very explicit that we only have bad options. And it's sometimes quite complicated. So for example, here there's a robber, some criminal, and then there's another criminal, and a homeless person, and a child, and a cat and a dog again. And yeah, the light is, yeah. So quite often it's actually like quite complicated. And maybe in a case like this, you just roll dice, and then kind of hope for the best. I don't know like how these methods should work. But yeah.
With respect to this discussion, I would like to bring a point. Does it not beg the question that AI is not creative and therefore should never be handed over the reins of life and death situation? One example, please allow me, the famous Sully-Sullenberger incident where the pilot did not have enough fuel to go all the way to the runway. So the human brain and his loads of experience made him to decide to land the aircraft, the jumbo jet, on the Hudson River. I don't think AI could, unless it's AGI, it could do that. So I would not want to fly a plane where there is AI flying the plane.
So for the audience, it's a good point that if AI is kind of like not creative, I think what is the balance between too creative and not creative enough? So, for example, the famous Hudson River plane landing case, where actually I think there's a long investigation whether the pilots did the right thing by deciding to land on the river instead of right away turning back to the nearest airport. And I think the investigation cleared them that they actually made the right decision, even if it was risky.
In the movie they did, I don't know about reality.
Yeah, I've seen the movie and read the Wikipedia article. That's my knowledge about the case. But that's probably a good example that if there would have been an AI, would it have been robust enough that it could have made a good decision, even if all those birds would have hit the engines? And it's quite unlikely that all engines fail in a plane. Usually just one engine fails and then you can still land. But in this case, something very unlikely happened. You were in a very long tail of probabilities, so to say. So is there any guarantee that an AI then, because that case is probably not in the training data, that the AI can then act in a reasonable manner that would lead to a good end result? And in that case, I would have been more happy to be in the plane with that pilot who happened to be quite experienced and skilled than to be in a plane with an AI pilot. Good point. So, related to that, suppose you have cancer and you have to choose between a black box AI surgeon that cannot explain how it works, but has a 90% cure rate, empirical, 90% of the cases that it has operated on have been successful, or a human surgeon with an 80% cure rate. Who would choose the AI surgeon and who would choose the human surgeon? This is maybe related to the plane example just before. So, what do you think? Would you like to be operated by an AI or by a human being? Who would choose the AI? It's a question there.
Not a question, but more like a statement. I was thinking about his example, and I think what is important is how or what the AI was trained for, because even in the crash landing situation, if you have an AI that has been super well trained to identify, in certain situations, what to do, where to land a plane, then maybe it's even better than a human, because a human is very emotional in a life and death situation, and an AI is not. And so here as well, if the AI surgeon, just facts speaking, is 90%, probably has been trained very well. So if you go by the numbers, I'd probably do the AI surgeon, because 20% chance to die or 10%, that's half. So,
So from the audience, the comment is that, well, if you have a life and death situation, like the plane landing or the surgery, then if the AI has been trained very well on the cases like these surgeries, then it could be a good choice to go with the AI. Exactly. If it's been trained. I think the question is more than what will the AI do if something surprising comes up? If it's something that wasn't in the training data. And of course, then you don't know, are you a typical case? Will there be some complications in your thing? So if there's something that wasn't in the training data that comes up, then I'd rather have maybe the human then, who maybe has a broader understanding of the thing. I don't know.
Why do you think that the human has a broader understanding?
Exactly. That's my belief. But then also maybe I can interact with the human beforehand, see who is actually operating me. But this might just be kind of me being suspicious about new technology. Because if the numbers are like this, so there's there's nothing unclear. The AI is by numbers better than the human surgeon. Comment.
Well, something to maybe take into account is the fact that the 80% cure rate could be lower than error, like maybe getting tired through the surgery and making a small mistake that the AI itself would not do. So I would personally choose to have the AI, and maybe at the time, if it's like still quite new, it would most likely have a supervisor that is human that would like watch over, not perform the surgery, but would watch over the surgery in case there's something unexpected that the AI wouldn't know how to handle. Stop it.
So the comment is that the human surgeon might in some cases be tired or make mistakes if the surgery is long or has had a long day and so on. And then the other point was that what happened? The other point was that then the AI would probably still have like a human supervising it and watching over what it does, and maybe then like if there's some like tricky cases, maybe take over or make decisions then if something surprising happens, which is probably true. So if we just like based on this, like who would prefer to be operated by the AI? Who would prefer for the human surgeon? I think like a small like majority would still go with the AI. Thank you. So, if you're not like afraid of AI surgeons, what should we be afraid of? Terminators? Skynet? I would say that we shouldn't actually be concerned or afraid of Skynet. I think we are quite far from that. So I wouldn't be concerned that machines become self-aware and take over. My concerns are more related to like ethical use of AI tools or the lack of ethics there, hidden biases that are hard to spot and see, and data security. And these are powerful tools, and they can be used both for good and evil. And I see that the evil part would be kind of misinformation and actually like spamming the internet with knowledge and trying to affect how people think. I think that's sort of an actual concern. So I tend to say that the social media is the opium for the masses of our time, and that's probably at least partially true and reinforced by AI now. But can AI still be useful, even with all those risks? So I would still consider like AI tools being a bit like asking your like younger sibling. I don't know how many of you have younger siblings. At least some, yeah. So like asking your younger sibling to help out with your homework and your things, or having a summer intern to like help you out with something. Your younger sibling might be super eager to do your homework, and probably they get something done, but before you hand in your course essay, you probably want to check that what your younger sibling wrote. Don't ask your younger sibling to write the essay for you. And of course, then if you think of them of like generative AI methods, they are actually great at automating things, scaling things up, even like complicated things that are so complicated that it hasn't like been like it means sort of senseless to try to code up some tool for that before, because now you can actually like someone said that the programming language of the future is actually English. So you can actually instruct these methods by just telling them in natural language what they should do. So it's actually never been this easy to build highly complicated IT systems. And in this sense, they have the potential to help and at least partially replace human decision making, at least on like on a lower level, to actually like autonomously like do summaries or help with drafting things. And well, with large language models, there are then like a lot of opportunities and threats. So if I think I generated this image, I was visiting a school, a high school. They invited me to talk about large language models, and kind of they were super concerned that the students then made all essays and stuff that will be written by LLMs in the future. So then I was kind of like thinking that it's a bit like these children's like looking down to the kind of like the bottomless pit of like hell in a way that kind of like it's easy to lure them in, but there are actually like really good things here as well. So things that cannot be done at scale in other ways are actually possible with these generative AIs. So actually like offering like tailored things, interactive help, highly customizable things, and also then like helping out in like brainstorming and feedback. So I think these are kind of the strengths. These are the opportunities of these models. While then there are the threats, like kind of like stagnation in personal development, actually sort of like not being able to produce text, kind of like if you're given like white sheet of paper, can you actually then like produce anything without the help? Then of course all the issues with copyright and other things that we talked about earlier. Is this like a path to decadence and corruption? I don't know. I'm kind of like partially concerned about like this excessive dependence. Like, will people be super dependent? I think when I went to school, people were saying that yeah, you cannot use a calculator because you will not be carrying a calculator around when you're an adult. Well, quite frankly, I am. That's just one of the many things my smartphone has. But that's how things were explained to me when I went to started my school. So if you're dependent on these tools, but they're always present, yeah, I still survive without a calculator though. And then of course then like all these privacy aspects. That's actually a concern I have. And well, once, a long time ago, the most valuable members of the community were really good at hunting mammoths. And that is a skill that we don't need anymore because we don't have any mammoths around. But also skills that we need to have in the society, that's kind of changing over the years. And maybe the mammoth hunting is a bit far-fetched, but typewriting with like old school typewriters. How many of you have ever tried an old school typewriter? Surprisingly many. And that's actually quite hard. It's different than typing on a computer. So, but that's still a skill that like if you were applying for a job, say 50 years ago, that was probably something that you needed to have for many jobs. But no one's interested in your typewriting skills anymore. Maybe your writing skills in general, but not typewriting skills. So these AI methods will become kind of like an integral part of the tool chains that we have. A bit like spell checkers. Like that's kind of like you don't even notice that your browser or Word or whatever you use probably has a spell checker on and can pinpoint when you're mistyping something. So I'm just saying that some skills might become obsolete, and then new tools are going to be a natural part of how we do things. I would still say that some critical skills we need to learn the hard way in order to actually be able to grasp the things. And I think critical thinking is just one of those. An example that I can like is that the daughter of a friend of mine had encountered ChatGPT. That's already a year ago, when it was still kind of new. And she was around 7 years old at that point. And she was super impressed by ChatGPT. And many of us, I think, when you saw ChatGPT for the first time, I guess you were impressed. Yeah. She was super impressed. Not about that it could produce coherent text, but about the typing speed. Because you know, the letters appear. And for a 7-year-old to type that fast, that's the impressive part. So kids that grow up now with these tools, they will not think that it's anything special about being able to generate images or generate text. That's how it is. It's a tool. Of course, there's always been around. A bit like many of you and the internet, maybe. And like my children, they don't understand the concept of linear TV, that you cannot choose what you watch. That's weird for them. That for them, you can always pause things. You can always pick what you watch. For them to understand that, no, you actually missed the program. Like, you cannot see it anymore. That's a weird concept. So for the youngsters who are growing up to be the next generation, I need to update my slides because there's nothing impressive about these things. And that's kind of like, I need to update them every year because things change so fast. So the things that were impressive 5 years ago, you wouldn't be impressed at all about those things. I removed those slides because, yeah. Okay, we have time for a quick recap. I'm just going to tell you that we are not going to stop here yet, because I've made this adversarial attack that prevents me from stopping by putting those stickers there. I tried to cover things in like societal impact, what is changing, what kind of role these things have. I tried touching upon fairness and biases, and this is of course a huge topic area. And I gave some examples that things are biased. Even if we try to make these models unbiased, quite often things slip through and they're still biased. And, well, transparency, accountability, and various ethical aspects, they are things that need to be taken into account, especially when, like, deploying things, actually making the products that people use. Me, of course, as like a low-level researcher, I design building blocks that are then stacked into actual products, typically by someone else. But I think the whole pipeline of looking at everything from the building block level to the final product needs to be there to build like better understanding about the weaknesses and strengths of the models we have. Okay, any questions about the ethical aspects or impacts? Should we do a quick recap of the course topics? Let's do that. Yeah, quick recap. This course had 6 lectures. I talked about what AI is. Then we went into machine learning. Then we took an even deeper dive into deep learning and reinforcement learning. And like these 3 lectures here, 2, 3, and 4, are basically on like sub-symbolic things. Then we had last week a lecture on search, logic, and symbolic AI that tried to kind of like give the other kind of like a bit of an orthogonal viewpoint on things. Things that are kind of like are human understandable. And then I kind of like the neurosymbolic things that tries to combine the best of both worlds. It's still early days, but there's something there. And today we made a quick dive into impact and ethics of AI. So this tries to kind of like cover different aspects and views of AI as a whole. And of course then you've learned now in the course that there's not just one type of AI. There's actually so many different tailored AIs for different tasks, different uses. And of course now the discussion is a lot about neural networks and generative AI. But that's just like one part of it. And remember that. We also have a visitor, and you had the opportunity to watch visiting lectures by other visitors from previous years. And I hope you got the idea that there are many views into these topics, and especially from the application area side, There's so many areas, and each application area has its own characteristics and challenges that need to tackle. The exercises try to kind of give you a bit more like hands-on view, partially to make things maybe less abstract and less scary in a way. So you started off by some warm-up reading tasks that hopefully then like you saw that they connected to things that you then like went back to then later on in the course. And then we had 3 computer exercises, one about text generation. And you used quite a simple generative text model, maybe not as impressive as say GPT-4 or Gemini or something like that, but maybe something that you see kind of the strengths and weaknesses more clearly than when you have something that is less polished maybe and with less parameters. Then you had an opportunity to generate unicorns in computer assignment B, actually using a quite small but still quite good, I would say. I'm very impressed by this model. You use stable diffusion for generating images. And then the last computer exercise was on reinforcement learning. Kind of a simple model. In the other ones, you run code on a pre-trained model. In computer exercise C, you actually also train the model. And for that, it kind of makes sense that it's a bit simpler. The last part that you still need to finish is the course essay. And this really is for you to reflect, because now you have kind of gone through 6 lectures, these exercises, and now you have kind of like, you know the terminology, you know different aspects to things, and then you come here to this course with your own expertise in whatever you are good at, either through your studies, work, hobbies. So the course essay should also be an opportunity to combine that knowledge you have from elsewhere with the course topics. Though remember that the audience that you're writing to should be the general audience on this course. So they might not have the special skills that you have from before. So motivate, explain to your peers in the essay. Then there's also a peer grading component where you actually then get to read each other's essays. And take that seriously, because that's actually then like input. So it's not only me explaining things from my biased point of view. You can also then learn from what others think. And every single essay is different from each other. So there's not just one topic that you tackle. So you will probably get quite different essays from yours to read. Good. Remember this blob? My biased projection, dimensionality reduction of AI into a couple of blobs. So AI, we have like these symbolic things. Then we have machine learning. I don't know how much of this full blob ML should fill. There's still room for inventing completely new types of AI. Maybe there will be new blobs in the coming years. I don't know. And then, of course, how this like then links to other fields like data science and statistics. There's a lot of overlap between these. And just to recap, like this course tried to be very, very general in how we view AI. So basically, like a system has chose adaption, something that can be used as a tool for decision making, or for computers to do things that if people did them, we would consider that intelligence. Or then one way also to look at things is that for AI is to explain how human intelligence works and how to reproduce that intelligence in computers. That's maybe not how I view my job, but that's like a kind of strong viewpoint that I think many have. I would still say that AI is not about solutions. So AI is not ChatGPT. It's not generative models. It's not neural networks. It's actually about the problems. How to make a computer do something. How to make a computer generate natural text. Understand the spatial surroundings around us, and so on. And I want to stress that it's really hard to come up with new things because people have these conceptions that they get from movies, books, comics, and so on. So very often people kind of might even think that something exists because they've seen a movie where it happened or it was there. So then like facts and fiction get mixed up in AI. Before, kind of facts and fiction were maybe further apart, but I think they're also then like coming closer together because many of the things that nowadays already work would have been kind of an act of fiction, say 10 years ago. Then I think there's a lot of things to tackle. So for example, these like misclassifications. So we humans, we have a lot of context. And we can probably say that, well, it's probably not ping pong balls in the fridge. But for example here, like the image prediction for these things, it's like 100% confidence that these are ping pong balls. And we're faced with like new type of challenges. Like I see these little guys drive around where I live. And actually like not many days ago, I actually helped one of them together with some other people because it was stuck. It had tried to cross the road and then there was still a bit of gravel and snow left and somehow it got stuck. So actually like kind of human in the loop in the way that it's not the AI assisting me, but actually also me assisting the AI in a way. And also then like for us to, we are easily kind of thinking that because something appears intelligent, it's human-like. Because it's very natural for us humans to kind of like see human-like behavior in other entities, animals, even I know if you talk to your plants at home, you might talk to your dog, you think that your turtle has feelings and so on. So for us to understand that these are actually cold algorithms that just crunch numbers. So for example here then like the artificial neural networks tell us about brains in the same sense as cars tell us about horses. So they serve a similar purpose, but cars and horses, you cannot analyze how a horse works by analyzing a car. And I guess the same goes for artificial neural networks and brains. I'm also saying this to you, even though I think that you are not in the risk group. But with all the buzz going around at the moment about AI, we should beware of all kind of charlatans, snake oil salesmen, and nonsense. Because not every person commenting on these things are experts. And we also tend to overestimate progress in the short run, while we tend to underestimate how things change in the long run. So be aware. This course is ending in 3 minutes, but there is more. More in terms of courses. So if you now feel that you actually want to learn about the methods, because much of what I've been telling you has been about the big picture. And then some of you clearly are hungry for actual technical details. So you should take the courses on machine learning, for example, to get started with the basics. Or the courses on supervised machine learning or artificial intelligence, where supervised machine learning goes through a whole bunch of typical methods in machine learning. The actual AI course that doesn't have the intro in it has a focus on symbolic AI. Then there's a lot of like more technical special courses, for example, deep learning, generative AI, there's a new course on generative AI starting. There's a good course on reinforcement learning and so on. Every special like technical area typically has its own course. There's so many more courses on speech, computer vision, you name it. And then again, if you're not into the technicalities, if you want to learn about applications, you are from different parts of the university. So I would be surprised if there is not some special course at least running that would cover things in your area. So there's like, the special courses come and go, but just to name a couple of nice examples from past years, Perttu gave an excellent course in like intelligent computational media, actually like hands-on work with neural network models and things for actual problems. And then there's, I'm not sure if it runs anymore, but there was a course on art and artificial intelligence, but there's so many courses on like material science, business, chemistry, and so on for AI. Keep your eyes open for those. Good, okay. One remaining quiz about this lecture. It's gonna open in a bit. Remember that. You will have 1 week to do that as always. You have your course essay. The deadline for the actual essay is on Monday at 6 p.m. And then you have time to do the peer grading. There's a couple of days to do that. And then you still have time to then like go through the peer grading you got and so on, comment on that. The course feedback, it's not Webrapol actually, but it's this new system. And some of you have already like filled that feedback, but remember to fill the feedback. That's actually the feedback that then goes also to the university administration, but then there's like structure questions for the lectures and exercises that you can like affect things for the coming generations. And for the trouble, you will get a couple of bonus points that are added on top of everything else you collect then point-wise. Good. Questions about, yeah?
Just a quick question. I saw that there's 2 feedback options. Like one is for mid-course and one is for like end-of-course feedback.
It's the end of course.
Because I don't remember there being a mid-course, or was there?
Yeah, the mid-course feedback I created, so it's been voluntary to fill in, but it's the end-of-course feedback that is the one that counts. Yeah, I think the mid-course feedback probably ends today. It's probably closed already, I guess. So, so now there should be just one. But it's the end of course feedback. That's a good point. Yeah. Good. I think it's time to say thank you for the course. It's been very nice having you on the lectures, and I hope we meet in the future as well. Thank you.